Alright, this set of notes is going to be on page 43, and the title will be Expanding Binomials. So turn to page 43 and make sure that you add your title, Expanding Binomials. So we can use Pascal's triangle to expand any binomial that's in the form of x plus y to the power of n. And that n can be any number. And we will use that n to help us decide which row for Pascal's triangle we're going to use. N is the row number of Pascal's triangle. So for example, if we are trying to expand x plus y to the fourth power, that means we are going to use the fourth row. And row 4 of Pascal's triangle is 1, 4, 6, 4, 1. And remember that we can use Pascal's triangle anytime we have two possible outcomes. So for this example, our possible outcomes are x and y. So thinking about what that means in terms of Pascal, our first outcome in row 4 could mean that we have 4 x's. And then as we're going to the right, we're going to decrease by 1 x each time. So the next outcome would be 3 x's, and then 2 x's, and then 1 x, and the last one would represent 0 x's. Thinking about what that means in terms of our y's, then for 4 x's we would have 0 y's. When we have 3 x's, we would have 1 y. 2 x's would mean that we would have 2 y's. 1 x would mean that we would have 3 y's. And 0 x's would mean we would have all 4 y's. So in order to use this to write our binomial, then we can say, well, there is one way to get 4 x's. And when we're expanding binomials, we're going to use the number of x's and y's, or a's and b's, as the exponents on our x's and y's to keep track of it in our binomial. So then we're going to go on to our second term. And our second term, there are 4 ways to get 3 x's. So we have x to the third and 1 y. Plus our next term, there are 6 ways to get 2 x's. So x squared, and 2 y's, y squared. And we can really think about this as multiplying the x's and y's. So this is really like saying we have x, 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 y, or x to the third y. So that example is when we have 3 x's and 1 y. The reason we can write that as x to the third is we're thinking about multiplying these all together. And 3 x's we write as x to the third. All right, let's keep going. So after the 6 ways to get 2 x's and 2 y's, we have 4 ways to get 1 x and 3 y's, so y to the third. And there is 1 way to get 4 y's, so y, and we're going to tuck in that 4 right at the end, y to the fourth. Right. So not only can we use this binomial expansion to help us expand anytime we have this x plus y to a power, But this can also help us with our probabilities and knowing that if I looked at this term in the middle that says 6x squared y squared, I can interpret that as there are 6 ways to get 2 of the first term and 2 of the second term. And if I wanted the total number of outcomes, I could add together the coefficients, 1 plus 4 plus 6 plus 4 plus 1, just like I would do if I was adding in Pascal's triangle.